Good morning, students. Today we'll learn something about microprocessor. Microprocessor is not a new term for new generation students because everybody now the uses electronic gadgets has a little bit idea about microprocessor, processor, chip, everything. So the fourth semester of electronics department has a syllabus that contains about the microprocessor and microcontroller. So I will start a short lecture video on microprocessor Intel 8085. Before going to Intel 8085, if a person understands about microprocessor, then he must know what is the evolution of microprocessor. Evolution means how it got started, in what steps it got improvised, and in what application those microprocessor are being used in the electronic gadgets. So my talk flow will have a outline like I will introduce something about microprocessor, including those evolution, and secondly, I will mainly I'll focus this lecture on features of Intel 8085. I'll let you know after some like few minutes that really Intel 8085, which is a very great invention by the Intel Corporation of uh, chip design, that really took place a vital role in designing the memory chips and IC chips. So I will my talk flow will totally cover today about the Intel 8085 microprocessor. And the microprocessor, what is inside that microprocessor, the bus architecture and the pin configuration will be today's discussion. As I told, microprocessor is not a new term for new era students, today's generation. Processor means it is the heart of computer that processes the data what is given to it. The input is given to the processor. It processes according to the instructions or command and gives the output. Now the processor, why it is called micro? Because when I am interested in assembling a single task computer, then the processor inside the computer will be a microprocessor. Means one dedicated task I will do with that processor. Then it becomes the microprocessor for a microcomputer. The evolution of microprocessor started with few steps. So it started like the microprocessor, Intel designed the first microprocessor, that is Intel 4004. Intel 404 is a 4-bit processor. 4-bit processor means at a time the processor can handle 4 bits of data. Either input or to display the output, it can handle 4 bits of data. Any numeric data or text we are giving to the computer, it will convert it into 4 bits format. That was good processor because it was a start. So everybody was quite curious about that processor. It could solve many problems that we wanted to using the processor. But the limitations were many because when the data range became vast, so we wanted to improvise the processor capacity by 8-bit, from 4-bit to 8-bit. So in subsequent years, in 1973, we got the processor Intel 8008. It is a 8-bit processor because 4-bit processor could solve many things, but the improvised one, the 8-bit processor. Now our data frame is increased. We can do lot many more tasks as compared to 4-bit processor. But that was using PMOS technology because chip manufacturing depends on like NMOS, PMOS, CMOS. These are the technology of semiconductor that is being used in fabricating the chips or the ICs. The Intel 8008 was using a PMOS technology where the mobility or the processing speed was bit low. So obviously then the second thought of designing another 8-bit processor came. So Intel 8008 processor was a successful processor, but having this limitation of mobility and having the less speed. So we got another processor that is again 8-bit in the year 1973 itself, Intel 8080. It is again a 8-bit processor, but the plus point was it was using NMOS technology. So improvised Intel 8080 is improvised over the technology in terms of data speed. Like 8008 was using PMOS having 8-bit size and 8080 was using NMOS having 8-bit size. So obviously this is faster processor than this. So both were successful, but again human needs are always endless. So always we want better and better year by year. So in 1975, uh, because why better? Because Intel 8080, this one was using NMOS. Speed was good, but the problem was it was using three power supplies for its operation. So power consumption was high. So again, this gives a negative pullback or throwback, that why should we use where the power consumption is more? We should go for another invention where the power consumption will be lower along with the NMOS technology. So in the year 1975, the first ever successful, most successful processor I can say, that was using 8-bit, that was the 8-bit processor using NMOS technology and using single power supply. So any student who reads about microprocessor must know about the operation, pin configuration, architecture, bus architecture, about the application of Intel 8085. This has become the basic building block of the further microprocessor. Though nowadays we are in the 64-bit processor era, but the student who wants to learn about 64-bit processor, he should know how the Intel 8085 processor works, being a 8-bit processor. So today's lecture we will try to cover something about Intel 8085. So special features are included. As I told, this is a 8-bit processor. It uses NMOS technology. It is a 40 pin DIP. 40 pin DIP means it is a IC having 20 pin and 20 pin both the sides in the IC form, and it uses a technology called DIP, dual inline package. The IC is manufactured in that style, and it is a processor having single power supply. The clock frequency is 3 megahertz and the clock duration becomes 320 nanosecond, and the address bus size is 16-bit wide and data bus size is 8-bit wide. These are the most important special features, students. You should memorize it, because whenever you are going to speak about Intel 8085, then you should know that if somebody asks you why Intel 8085 is very famous, then you should enlist these points first. Then obviously the architecture and bus architecture, pin configuration will be in line to make somebody understand. But these points you must remember always. Bus architecture. As I told, Intel 8085 is a 8-bit processor having 16-bit wide address bus. The bus architecture looks like this. It is a processor, microprocessor unit, Intel 8085. As you can see, as we know, any processor has three best friends, because it has to always interact with memory, input device and output device. So if this is my hero, Intel 8085, I have kept three best friends to the side of it, that is memory, input device and output device. So how they are connected? We connect our friends through our emotions and our friendship. Then machine will not understand the emotion and friendship. It has to connect with their best friends or the peripheral devices, we call it, by the buses. Buses are nothing but transportation system from the processor to the peripherals. Now the peripherals are three: memory, input device and output device. So processor has to communicate these three. So to connect we have three buses, because bus, what we do by bus? We stand in the bus stand, we get into the bus to go to somewhere, or to get ourselves dropped at some point. So similarly, if processor wants to give some signal to memory input device, or to get some signal from output device, to output device, or get some signal from input device, then it has to use the buses. So buses are three: address bus, data bus and control bus. Address bus is 16-bit wide. Intel 8085 has. All different processor has different address bus sizes. But specifically we are reading about Intel 8085. So there the address bus size is 16-bit. We say it 16-bit wide, and data bus size is 8-bit wide, and control bus unidirectional. Address bus size will help us in locating the address of the peripherals. Data bus will help in communicating the data, and control signals, what to do, what not to do, when to do. These are the signals that is being carried by the control bus. Now see, 16 bits wide means A0 to A15 address bus, 8-bit wide means D0 to D7 data bus. Control bus has no bit size because it has to give any control signals like clock signal, read signal, write signal, latching signals, all are the control signals. So no, bit specification. So these are very important question I have asked. If address bus and data bus are the communicating device, communicating means to the peripherals from the processor, then what exactly it signify? So two questions you must ask always to yourself, that what exactly size of address bus gives information and what exactly size of data bus gives information. So it is a very important question. You should know address bus size gives the idea about memory allocation capacity. As we know, processor is nothing without memory. Bestest friend, I can say. If processor has to process any data, then always it has to interact with the memory. From memory, it should take data. To the memory, it should send the output data or the process data. So what size of memory is really fitting to the processor? If I am a processor, then to me what kind of memory is compatible, that I should know, and that idea is given by the size of address bus. So for example, if Intel 8085 is a 8-bit processor having 16-bit wide address bus, then its memory, the memory that we should buy for it is 64 KB, that is to the power 16. So 64 kilobyte is the perfect memory for Intel 8085. We cannot go for MB or we cannot go for GB because its address bus size is only 16 bit. So we have to have the compatible memory for it. So this is the vital question anybody can ask to you when you are going to tell something about microprocessor. So 16-bit wide address bus means 64 KB is the memory size. It should be. Similarly, data bus size. Any processor you are going to market to buy a processor, then what you should say? Give me 8-bit processor. 8-bit processor means what? The data handling capacity or word length. We say it word length. Word length means at a time the processor's capacity to handle, to process or to give output. What is the data size? Means if Intel 8085 is 8-bit data size, data bus or 8-bit processor, then its data handling capacity is 8-bit or word length is 8-bit. So this data bus size is enrolled in these three capsules: 8-bit data bus, data handling capacity and word length, all are same. So this information we get from the data bus size. So there are two information hidden in the address bus and data bus size. Here comes the most important part of Intel 8085, that is pin configuration. Students, you must memorize all the pins. It looks very difficult, but I will make it simpler. Because as I told in the intro that 20 pin both the sides, we have 40 pins in the Intel 8085 chip. Now you see both the sides there are 40 pins. You have to memorize it, but that is a trick. Like you see AD0 to AD7, these are called address data multiplexed lines, and only A8 to A15 as the only address lines. Total address bus is 16-bit. It is divided into two groups, lower order address and higher order address. Lower order address is multiplexed with the data bus to make address and data line, and only higher order address is placed like this. So this is bidirectional because the data is involved, and this is unidirectional because only address is there. So with that, some extra pins are there. ALE, that stands for address latch enable. Address latch enable means when the higher order address bus latches with the lower address bus to make a full address, then this signal has to be high. Similarly, hold in HLDA, these are the two signals requesting for the use of buses, because bus has your processor has the capacity to hold the control over the buses. If another device is requesting for the control over the buses, then it has to hold the current task is being performed by the processor. Similarly, trap, RST 7.5, 6.5, 5.5 and 9-tier. There are 5 signals at a stretch. You can see pin number 6 to pin number 11. That means these pins are interrupt signals. Means they request the processor to hold their task and to attend them. These request signals are sent by the peripheral devices like input or output devices. And INTA bar is the acknowledgement signal. When some interrupt signal is given to the processor, in CPU acknowledges through this INTA bar signal. Reset in bar, ready, reset out, these are the signal where we try to let the user know where the CPU is reset or CPU cannot take any data for the processing, or it is ready for the data communication or not. These are the pins, and these are active high. Always they are high to let the user know where it can be used for the buses or not. SOD and SOD are the serial output data line and serial input data line. If some data is taken from input, then SID is high. If data is given from the processor to the output device, then SOD is high. SOD means serial output data line. Similarly, IO bar, IO/M bar, S1, S0 are the control signals, whether the signal is for input output devices or for memory. And similarly, clock is the 3 megahertz, we know that, and power supply is plus 5 volt. X1, X2 are the two external signals. If processor is unable to connect with the external device, then with the help of extra X1 and X2, two external pins, we can connect to any other devices. Dedicated input output devices, they are already, but we can connect them extra input output devices. So students, I think you have got an idea how the processor size can be defined, how it can be used for further processor, what is the pin configuration of Intel 8085. In next class, we will try to cover about Intel 8086, which is a 16-bit processor. Thank you.